All right, let's get into it. We're doing a deep dive on something that, well, on the surface, it just looks like a simple cable, but it's actually a real marvel of engineering. We're talking about the Kramer CLS-AOCU32-FF-66.
Yeah, and our mission here is to really get past the spec sheet.
Yeah.
We want to understand the single biggest problem this thing solves. I mean, why would a professional even need something called an active AOC hybrid cable?
And you see the problem right away when you look at the numbers. It's 66 feet long,
Mm-hmm.
and yet it promises 100 watts of power, 10 gigabits per second of data, and full 4K video at 60 hertz. I mean, that combination over that kind of distance,
Yeah,
it just shouldn't work, right, physically.
exactly. It seems impossible with normal wiring. So what you're looking at is a USB 3.2 Gen 2 superspeed plus a full-featured USB-C cable. And that full-featured part means it has to juggle that absolute triple threat all at once.
The power, the data, and the video.
All of it.
Okay, so let's start with the video quality. It says 4K at 60, which is great, but it specifically calls out 4.4.4 color depth. So why should, the person actually using this care about that specific detail?
Well, 4.4.4 is critical if you're doing anything with serious video editing, digital signs, that kind of thing. It means zero color compression.
No artifacts.
Right. If this cable was limited to, say, 4.2.0, your colors would look noticeably worse, especially in scenes with a lot of motion. So getting that uncompressed quality over 66 feet while a 10 gigabit data stream is running right alongside it, that's the real win here.
And speaking of wins, that 100-watt charging capacity, that's just staggering when you think about the resistance of wire that long. Wait a minute, how does that even work? Wouldn't 100 watts just get lost to heat and voltage drop over 66 feet of copper?
That's the key. That's why it has to be a hybrid design.
Okay.
A standard copper cable just can't do it. The
Right.
signal degrades too much. So the solution is to divide the labor. This cable uses fiber optics for all the high-speed data.
So the 10 GBPs data and the 4K video, that's on fiber.
Exactly, because fiber doesn't suffer from that kind of signal loss.
Yeah.
But then the power, the full 100 watts, that still runs on traditional copper wires inside the same jacket.
So it's both.
It's both. And that active part, the A in AOC, means there are tiny chipsets in each connector managing that signal, converting it, and boosting it to make sure you get the full speed at the other end.
This completely changes how you design a system. Before, if you wanted a high-res camera 60 feet away, you'd need, a separate power cable, signal boosters?
Mm-hmm. And a bulky HDMI or DisplayPort cable, it was a mess. Now it's just one plug.
And that thinking extends to the little details, too. I saw the jacket is LSHF, low smoke halogen free.
Yeah, that's a huge safety feature. It's not just a checkbox. It means if there's a fire, this thing won't fill a server room with toxic black smoke.
And they even thought about the physical connection. It has this K-lock mechanism on the USB-C plugs.
Which is so important. If you're installing this in, say, a conference room floor box, you can't have someone accidentally tugging on it and shutting down the entire presentation.
Right.
It's just all about reliability. It's built for these tough professional environments. You get connectivity, you get power, and you get all the safety standards in one, pretty thin 5.8 millimeter cable.
So when you boil it all down, what this cable really shows you is the absolute peak of what USB-C engineering can do right now. It takes 3 essential functions and puts them into one single, reliable, long-distance link.
And that brings up a really interesting thought for the future. I mean, we're now reliably pushing 10 gigs of data, high-fidelity video, and 100 watts of power over 66 feet. So if optical fiber can now do all that, what's stopping the next advancement from totally eliminating the need for separate local power supplies in, say, huge AV installations?